Hey folks, Chris here. I'm going to do another quick vlog entry while I work on these other projects that have been keeping me pretty busy. But I want to talk about an aspect of my solar setup, something that's really important dealing with cable thicknesses and batteries that I learned, that I want to pass on to you so you don't make the same mistake that happened with my system when I was initially installed. What I want to impart to you is that when you are putting a battery bank together, use the thickest cable sizes that you can use. My system now uses 1/0 cable sizes. When it was initially installed, the installer used 4-gauge wire. And I came to find out that that really was not optimal. And that knowledge kind of came about because of another sort of installation problem in my system. So that's what I'm going to talk to you about in this video. So what I learned is that when it comes to connecting batteries together in a battery bank, you really want to use the thickest wires that you can use. So let me talk briefly about a couple of concepts of electricity to help us understand why this is. If you're brand new to this solar thing, or you're investigating the solar thing, you think you're going to get an RV or a van and you want to put a solar setup, it's really important for you to do some research to understand some basic concepts of electricity. So we have 3 terms and a 4th that I'll kind of throw in here in a minute that are really commonly used to understand electricity, and that is watts, volts, and amps. Sometimes it'll be referred to as amperage. And as far as the battery interconnects go, there's also the 4th term, which is ohms. It's an issue of resistance. So if we talk about battery connections, we're going to be talking about connecting them with cables. And the electricity has to traverse the cables from one battery to the next. And those 3 terms, watts, volts, and amps, the one that really is intimately tied to the thickness of cables, where cable thickness is really important, is amperage. So let's just talk about this really quickly. Watts is a combined term describing both volts and amperage. Volts is electrical pressure. That's like water having a pressure in a tube, for instance, or like a hose, where the RV's native water lines like to exist in a PSI of 40 to 45. So volts is like that. Volts is electrical pressure. And the common electrical pressure in homes is 120 volts, although there's a bit of a range. Sometimes you'll see 110, sometimes you'll see 115 or 120. But they're referring to the same thing. In the RV, we're working with a lower voltage system in the direct current arm of the RV's electrical system. And that's referred to as a 12-volt system. Now, when you have lower voltage, you're going to end up moving the electricity in higher amperage ratings. And that higher amperage ratings is going to necessitate thicker wires. So if you take anything away from what I'm telling you right now, sort of take this understanding away that amperage is intimately tied to the necessity of understanding wire gauge size. Okay, so that's the critical thing to understand here. Now, I mentioned ohms. Ohms is a measure of resistance, and resistance is going to come into play here too, so I'm just mentioning it. There was a mistake made in the installation of my battery monitor, and I had to track that down. And it really produced a lot of anxiety for me because I was so new to this that it just was crazy making. And I spoke to a bunch of people in an online forum that deals with mobile solar, and I got a pretty good understanding of kind of what was going on based off their feedback of me describing the problem. And I'm going to do a whole separate video on that because that was a whole other interesting thing. I needed to go back to the people that installed my solar and say, hey, we've got to fix this. But in the process of me trying to understand what was going on, I contacted the manufacturer of my inverter because I was trying to figure out if maybe there could have been a problem with the inverter. And it turns out that their tech support was super awesome. And I'll put a link down to the inverter that I have because I'm really liking it. It's a 1500 watt pure sine wave inverter. But one of the things that came of my conversation with their tech support person was a conversation about the wire thickness in my batteries. And he said, well, what is the gauge size? And I said it was 4 gauge. And he says, that's too thin. He says, that'll affect your system performance. And he says, you really need to have at least 1/0 cable sizes. So you have 6 gauge, 4 gauge, 2, 1, and then you go from gauge, you go into 0 sizes. So you go down to 1/0, 2/0, 3, 4/0. And those become thicker and thicker. And so he said, you're going to get better system performance by that. So you can see by looking at this chart that I got from Wikipedia right here, comparing the 4 gauge wire that was originally installed in my system with the 1/0 cabling, that even just glancing at the values, if you don't immediately understand them, you can see significant differences, both in the diameter in millimeters and in the total area. This larger area means that cable can transport more electricity and with less resistance. And in fact, when we look at the resistance down here of the 4 gauge versus the resistance of that 1/0, it's clearly visible that the 1/0 has less resistance. But it's coming over here when we look at the ability to transport amperage, that 1/0 cable is going to be able to transport a lot more amperage. But I think really the significance is right here in that 0.3224 resistance value. I really think that's the value that the tech support person for the inverter was really pointing to me. And when we take a look at this picture right here of my actual battery setup, you can see this is the 1/0 cable. You can get another glimpse of the 1/0 cable right there connected to these big copper lugs. For comparison, there is a 2 gauge wire right here that goes to the inverter, and this came with the inverter. This was specifically designed to transport the amount of energy that that inverter could handle, and so it's perfectly sized for going from the battery to the inverter. So if you think about going from this 2 gauge down to a 4 gauge, that 4 gauge would be thinner than this, and it was originally what was connecting the battery. In the short period of time that I had been using my solar setup, I had noticed that my battery voltage by the end of the evening or by morning was down into the 12.1 range, and even with my limited understanding of how the system was behaving, it did seem like it was getting down a little bit low. So I went back and took my RV. I'd made an appointment to go back to the RV place, and I described to him the conversations I had with both the online forum and the tech person. Everyone agreed, hey, look, the thicker cables are better. So I decided to go back in and pay them to 45 minutes of time. The guy was really quick. And he says, look, we don't have those 1/0 cables here in our shop. But he says there is a welding supply place a mile and a half from here that we use when we need to get certain things. And he says they're great. Go in and get 10 feet of 1/0 cable. And he says, I'll splice that up. I can connect it with battery lugs. We've got those copper battery lugs. He says, I can work with that. Totally no problem. So I went in there and I was really worried because I had previously gone on to Amazon to look for battery interconnects that were 1/0, pre-cut, everything put together, and they were pretty expensive. They were like $30 a pop, and it was going to cost me $150 or so to get those on Amazon. So I went into the supplier, the welding supplier, and I said, I need 10 cable of 1/0, or 10 feet of 1/0 cable. And it turns out it was really high quality. It was solid twisted copper. It was not aluminum with a sheathing of copper. And it turned out that 10 feet was $30. Right? It was awesome. So I took it back in, and the guy was able to use it, and he replaced the 4 gauge, and he also replaced some of the the grounding cable, so it also had that thick, and also strung it between that and the converter. In the process, he said he found a couple grounding cables that had excessive length to them, and he cut out all the excessive length and put it back together. So that excessive length in a direct current is going to cause voltage loss. And that comes down to the Ohm's law thing, where you're going to have what's called voltage loss. And so the optimization of my grounding cables and replacing the interconnects in a few other areas with that thick 1/0 cable has definitely made an improvement in my system. I never get down to 12.1 anymore. By the time I wake up in the morning, my battery voltage is down usually about 12.4 to 12.45, and then that's where it ends up being by the time the solar starts recharging everything. And by the time it's recharged, the resting voltage is about at 100% is between 12.7 and 12.8. So that's where by the time the sun goes down, I'm right at that, and then it slowly goes down to the 12.4, and the whole cycle starts over again. So anyway, I just wanted to impart that to you, and I'm going to show you these charts along the video. I'm going to show you some of the reasons why this 4 gauge was not quite good enough and why the 1/0 was better. And I gleaned a chart from Wikipedia that has this information, and I'll kind of show you that throughout the video. Anyway, I just wanted to impart this to you so that this could be useful information for when you do your own solar install. Use thick battery interconnect cables.